when we have a complex number, it has a height y on the imaginary axis and it goes over x on the real axis, and so we can make a right triangle here, and if our argument of z is theta, then theta here is going to be this angle, and so we can say opposite over adjacent, tangent of theta equals y over x, and that is how you calculate the argument of a complex number. So I have two example problems that we're going to walk through then to just make sure that we know how to do this. So tangent of theta 1, since this is z sub 1, is going to be 2 over 2 y component and the x component. So that means that's equal to 1. And there's two things you have to consider. First of all, the tangent of theta equals 1. You also need to consider what quadrant the complex number is in. I'm going to just draw a rough diagram here. X is positive, y is positive, so z sub 1 is in the first quadrant. That means that if tangent of theta equals 1, theta sub 1 equals pi force. We need to consider what quadrant the complex number is in. So since x is positive and y is positive, the complex number is going to be in the first quadrant, and theta sub 1 is equal to pi force. For z2, we have tangent of theta 2 is equal to negative root 3 over 1, so negative root 3. And if we're just going to do a quick sketch, x is positive, y is negative, we're going to be down in the fourth quadrant. That tells us theta 2 equals negative pi thirds. So what this means is that for this complex number, the complex number is pi force rotation above the real axis, and since this angle is negative, we know that our second complex number is pi thirds of a rotation below the x-axis.